Hello everyone, welcome back to geometry. Today we're going to be looking at triangle proportionality. So when a triangle contains a line that is parallel to one of its sides, the two triangles formed can be proven similar using the angle-angle similarity postulate. Because the triangles are similar, their sides are proportional. So we have theorem 3.8 and theorem 3.9, which is the converse of theorem 3.8. So we're going to use the triangle proportions to find the length of the side. So if triangle BCD, or in triangle BCD, PQ is parallel to CD. So PQ, this is parallel to CD, this right here. If QD is 14.5 and BP is 9 and PC is 15, what is BQ? So what is this right here? So based on our proportionality theorem, we have that BP over, so BP over PC equals BQ over QD. Again, this is the triangle proportionality theorem. Now we can sub in what we know. So we know this is 9. We know this is 15. We don't know what BQ is. That's our unknown. And we know that this is 14.5. So I'm going to cross multiply these. So 15 times BQ. If you want to replace BQ with X, you can. 9 times 14.5 is going to give you 130.5. Divide both sides by 15. Divide by 15. Divide by 15. We get that BQ equals 8.7. So BQ is 8.7. Example 2, we want to use triangle proportionalities to determine if the lines are parallel to each other. So we need to show that WJ and JX is equal to YL and LX. So in triangle WXY, YL is 5. So this is 5. LX is 20. JX is 4 times as long as WJ. So whatever this is going to be 4 times that. So what we want to do is we want to set up proportions. We want to set up ratios. So we have WJ over JX, and we want to show that this is equal to YL over LX. So let's start off with this one. This one's still going to be the trickier one. We have that WJ over JX. Well, WJ is, as we said over here, it's X. JX is 4X. I have something common between the top and the bottom. I have the X that's common between the two of them. So I can divide out the X from top and I can divide out the X from bottom. That leaves me with 1 over 4. YL over LX. YL is 5. LX is 20. So I can divide out top and bottom 5. That gives me 1/4. Well, 1/4 equals 1/4. So or therefore, JL is parallel to WY. Again, this means parallel. Midsegment in parallel lines. A midsegment of a triangle is a segment that connects the midpoints of the legs of the triangle. Every triangle has 3 midsegments. The midsegment of this triangle right here, A, B, C, are RP, PQ, and RQ. So let's take a look at example 3. We'll come back to the corollaries on tomorrow's video. So we want to use the triangle midsegment theorem. So in the figure, EF and DE are midsegments. So EF and DE are midsegments. We want to find what the length of DE is. We know that this angle right here is 82. We know that this length is the same as this length. We know this length is the same as this length. And we know that this length is the same as this length. So that means this length and this length are both 7.5 because that's going to be half of 15. So DE, by the formula, DE equals 1/2 AC. Well, we kind of already figured it out, but we're going to show the work. Again, this is midsegment theorem. So this is going to be DE equals 1/2 times 15. So DE equals 7.5. So we took a look at triangle proportionality theorem, and we took a look at the midsegment theorem. Tomorrow we're going to look at the corollaries. So go ahead and review the video, and then write a quick summary off to the side of what we've learned so far.